the new ways incorporates the modern scientific principles and exposes students to new scientific skills, and just shows them a link between the old Aboriginal ways of doing science and the new. So, welcome to my chemistry class. As I said, I work as a chemist, and that means I play with chemicals. Now, the first rule when you come into a chemistry laboratory, and we're going to pretend we're in a chemical laboratory today, is you don't touch anything. Why do you think I would say that? Why would you not touch anything when you walk into a chemical laboratory? Yes?
Because there could be chemicals.
And the chemicals could be?
Dangerous.
That's right, they could be toxic, they could either burn you, poison you, and therefore you don't know. So the first thing you do is you walk in, you don't touch anything at all, you just observe and listen. Of course, chemicals should be labelled, and I do have labels on the ones you have here, but some of them may not have labels, so you don't know. Now, I've got 2 activities planned for you today. The first activity has to do with forensic chemistry. Now, I have a question for you. When the police go to a crime scene, what is the one piece of evidence that they collect? I think you had your hand up first.
Fingerprints.
They collect fingerprints. Excellent. Why would police want to collect fingerprints?
So they know who the person is?
So they know who the person is what? Be clear with your answer.
Victim. The victim.
The victim or the
person?
person who committed the crime, most likely. Because the victim might actually be there. Maybe. Okay, so what is it about the fingerprints that will help the police to identify the person? Think about it before you put your hand up. What is it about the fingerprints? Yep.
All fingerprints are different?
Excellent. So all fingerprint patterns are different. So everybody has a different fingerprint pattern. Okay? Now, so when you go to a crime scene and you swab a surface, for example a table, and you get the fingerprint, you take a photo of it, you put it into a database on a computer. The computer tries to match it with the available fingerprint patterns. So if you've been involved in a crime previously, then your fingerprint pattern is stored on a database. So this is why it's not a good thing to commit a crime, because what will happen is they'll put it into a computer and your fingerprints stay there forever. And even though we do have a very good pattern recognition system on the computer, there is always a possibility of a mistake. So you could be, and I'm sure you have heard about, that some people have been put in jail, not so much these days, but many years ago, incorrectly. Because the evidence pointed that that person was involved in a crime, and years later they found out that was incorrect.
No.
So what I'm saying to you is probably better not to ever commit any crime, because then you will have your fingerprints in a database and you might one day be linked to a crime that you haven't committed. Now, what about this? We said that everybody has a different fingerprint pattern. What about if you have an identical twin? And having an identical twin means you have exactly the same DNA. What about fingerprint patterns? Any ideas? What do you think?
Still different?
They'd be still different, that's correct. Otherwise, you can blame your twin on whatever you've committed. Alright. Okay guys, we're going to get started. So the first activity is fingerprinting. What we're going to do is get you to fingerprint your thumb. Can you see the fingerprint pattern if you have a close look? You sort of can. Might be a little bit, for some of you, depending how deep it is engraved. However, if you were touching the table or any pieces of paper, would you see the fingerprint pattern that you left behind?
Yeah.
No, you wouldn't. You would?
No. Yeah. I don't know. No.
Well, put a thumb on the table. Can you see the pattern?
Yes.
Yes, I can still see it.
What did you say?
Well, it disappeared. You can see you've got left a little bit of sweat. It is actually difficult to see the fingerprint pattern if you leave it on a surface. So what we have to do is expose the fingerprint pattern so you can see it clearly and then take a photo of it. So what we're going to do is use the oldest method of fingerprinting or rather exposing fingerprints that has been around for many, many years. It's called iodine fuming. Now, iodine fuming involves using an element called iodine. It's this blackish, dark, it's actually purple, but it looks like a black solid at the bottom. Okay, that's iodine. Now, in front of you, I have placed colourful periodic tables. Can you see them? It's a bit hard not to see them. Can you find me the picture which has the element with the letter I?
Yeah.
That's iodine.
Where?
Have a look if you can see the picture. And if you can see the picture, tell me what it is. Raise your hand. I think this lady here was first. Yes?
It looks like a boy.
Doing? What's he doing?
Putting something on his knee.
Putting something on his knee. Has everybody found iodine?
Yeah.
Yeah. Noise.
So what's the boy? The boy is actually placing betadine. Have you heard of betadine?
Yeah.
Okay, so betadine contains iodine. Now obviously not in this form, it's in a liquid form, okay? Now what's interesting about iodine is, I'm not sure if you can see this, I'm going to put it against my white lab coat. Can you see that there's like a purple tinge inside the jar?
No.
So what is happening is the iodine is converting from a solid to a gas. Now is that a normal change of phase that you would expect from a solid to a gas? What would you normally expect to see if you have a solid like a lump of ice and you try to heat it? What would happen?
Solid to a liquid.
To a gas. Excellent. Solid liquid gas. But this one goes directly from a solid to a gas. So that's very, very interesting. It's a very unusual property. And it's actually a very useful property because what we can do is we will develop the fingerprint patterns by using the gas that's in the jar. I need you to place the touch it with the corner of your finger to hold it still, and on the top of it, just write in small letters your name, your first name, or if you want to put a little star or a circle to identify you. So let's do that. We're going to come around and connect the fingerprints.
Is it yours?
Ready?
See mine.
Doing.
You done
Yes,
it?
it's working.
Right, so place it in here.
It's not like mine.
Miss, I can't see mine.
Yeah, of course you can't see. That's why we're going to do
I can see mine.
Pass it down, please.
Wait, is it? Perfectly.
Sorry. Okay. Alright, ladies and gentlemen, my fellow scientists, I'd like you to now place the safety glasses on your eyes.
Oh, the safety glasses.
What are these for?
Just in case you get
We are
blind.
ready to start. While we're waiting for the fingerprints to develop,
Ah.
we are listening. While we're waiting, we are listening.
Oh, I have, but it's not working.
And listening requires no mouth movement. Ta-da! Okay. The second activity involves you playing with a very new type of compound called polymorph. This is a very new compound that not many people actually know about, so you're very privileged to have access to this. Have a look in front of you, have a little container. For some it's labelled, for some it isn't.
Drugs.
This is actually, no, it's not drugs, it's a polymorph, which is a type of polymer. It is used to make plastic. So everything that's plastic is actually made out of polymers. Now what we're going to do, Sunday?
Yeah.
I know. I know lots of things.
What's his name?
Now do you want to continue doing our activities?
What's my name?
Now, what we're going to do is I'm going to show you how this polymer, observe what it looks like. What do you see? What does it remind you of? Little balls, little white pellets? Yes?
Little ball.
So this is the observation you're making now. What we're going to do is I'm going to get you to transfer the contents of your container into the beaker, please. And then we're going to add hot water. So let's do that now, please.
Miss, we put all of it?
Transfer the whole lot. Yes.
I'm scared. Uh-oh.
Yep, just the whole lot, please. Are you having trouble?
Look at those tiny balls.
I
I'm gonna smell it.
Put it inside your brothers.
Alright, Okay, guys. Have we all done that?
Yes.
Are you going to do it? Yep. What we're going to do, Caroline is going to come around. Listen carefully, please. Okay, Caroline's going to come around. You in some trouble? No.
Temperature.
Caroline, listen.
You're gonna use
Little glass ball.
Please place it down. Caroline will come around and she's going to pour some hot water. It's about 70 degrees, 60 to 70 degrees, a bit more, which means very hot. So when she pours it into the beaker, as soon as she does that, you start stirring your polymer, okay? And observe what happens. Please be careful, the water is hot. Hold the beaker from the top, because it's not going to be hot at the top. Okay, let's go.
Try this at home.
Yeah, try
These are not safe.
So we're going to shape it into this. Okay, I'm going to now take this out here. I'm going to take it out to you.
Observe what's happening.
No wonder I use it to make graphics.
Look at it. Why would it be working? Oh, it's all sticky.
Hold it.
Oh, look, it's a ball.
Yep, you need to so quick.
I'm getting smaller.
It's not stirring though, it's just sticky. Oh, that hurts.
That's why you need to hold it at the top. Yep, just at the top.
Well, too weird.
I probably flatten it.
Start stirring fast.
I'm stirring it all. I'm doing exact as Nathan.
No, you need to hold it. I'm holding it. That's it. Perfect.
Oh, you can shape it.
Keep it in. Keep it in, otherwise it won't work.
I wish I had
And when you observe the change, it doesn't need to be that fast. They were a peak white ball.
Start shaping it into a shape.
Oh, a boomerang.
Boomerang. We're making boomerang.
They need to be protecting your eyes.
Oh, that feels so cool. Can I put my hands in the water?
No.
Can I take it out?
There you go.
How will do that for you?
Can you? Yeah,
Quick, because it's going to start hardening, so you have to do this quickly. I'll show you. Okay, you guys are ready? No.
Oh, good.
There you go.
I'd rather do
Alright, shape of a boomerang. That's not a boomerang.
How do you do a boomerang?
And then,
It's like
Just don't put it on the table because it may stick.
there you go.
it never come off.
What a boomerang looks like.
It will solidify.
Guys, here. What are you doing? Roll it. And then bend
You'll
it.
notice a change. So it went from those opaque white spots. Then it went into see
Everyone like mine?
sticky stuff.
Let's read it, Cupid. I want to throw it anymore.
That's right.
How?
Never mind.
Just to have a quick chat to you. What observations have you made with regard to this polymer? When we put the hot water in, what happened?
went clear.
So they stuck to excellent. They stuck together. The little white pellets stuck together, coagulated together. It went colourless and clear. And when we took it out of water, what did you observe? It was really soft.
Yeah.
And you were able to mould it into any shape you like. Do you think you would have been able to mould the original pellets, the white pellets? No way. Okay. You'll find that it should harden. Now, in the meantime, Caroline is coming around giving your fingerprints. Don't touch them yet, please. Just let them sit there. What I need you to do now.
Wow.
What I need you to do.
Look at mine.
Okay. Are you seeing how it's slowly hardening? And it's turning what colour now? White. Back to white. Yes, it is. So just place this on the table. Let it cool off and harden. It's okay. Show me. That's good. It's not bad.
It's a mouth guard.
No, it's not. It's a boomerang. Look.
Is this a boomerang?
Perfect. Look at that. That's nice. Okay. My fellow scientists.
Is this good? Coming together.
Yeah. You know, sometimes. Oh, there we go. Just make it a bit more like this.
How come hers is a different colour from mine?
Now, what are you noticing? Is it going hard?
Yeah, it's going
And
like
it's going back to
white.
to white. Exactly. So, very interesting polymer where you've got changing properties depending on the temperature. Now, I've got another activity for you, so we're a bit pushed for time. So place your boomerang just on the table. I'm just going to take away the hot water for us. The second activity is a fun activity. And take a spoon.
Red, you have pink. Purple on it, blue. And then you want blue or pink.
Now, I want you to look at what you've got and describe to me, what does it look like, that solid you have? What does it look like? Powder? Okay, what
Smells like oranges.
does it?
And lemon.
Interesting.
Yeah, it does.
And
Lemon and orange
Right.
juice. Is this
Tonic water. Orange juice.
Okay, what we're going to do is I'm going to come around and give
smells
you,
like fruit cake. Some water.
that's all right.
Orange juice.
I'm going to give you some water, green coloured water. And as soon as I give you the water, start stirring with a spoon. No,
Do we pour it in here?
use the spoon. No. Keep it all in the cup. Ready?
Oh yeah, it's gonna explode. Jokes.
Start stirring.
It's going to turn to paint.
There you
Well,
go.
we can drink that.
No, you can't. See?
Well, isn't that toxic water?
Now, what I want you to do is observe what is happening. What is happening when I add the water?
Oh, I'm scared.
They just use the bottle.
Any ideas what I'm making? What I'm getting you to make?
Paint.
Paint. Oh, it's paint. No, it's not paint.
Glue.
Smell like.
Explosion.
Glue.
Keep stirring. Hold it because it's going to
Oh,
tip over.
I know.
Glue.
No.
Ah, someone's
Jelly.
saying glue, jelly. Well, actually, you know what you're making? You are
Jelly.
making slime. Yeah. Show me. Perfect. Now, listen up. Slime has to be gooey. Now, this is a little bit too hard. So you have two options. If your slime is not slimy enough, I need to give you more water. If your slime is too liquidy, you need to add some more solid. So let me know. This is already, keep stirring. You need more water.
That's good.
You need a lot more water. That is almost perfect. Yep, keep those. You've got a bit more solid at the bottom. See?
Looks like jelly.
Show me.
It smells nice. Can I eat it?
Can we eat this, miss?
No, it's slime.
No, it
You don't know what's in this water. It's like green.
It's food coloring.
I want to
Is this
check
slime?
out the best
I need
slime.
heaps more.
slime?
Is this edible?
That is perfect. Show it to Brian.
And what about this one? Oh, and this.
Show me.
This. What about this one?
Do it again.
This one.
Oh, look at
Ruby's one. Look at this.
And you
I
guys,
need more.
Excellent. Show me.
Look at mine. Is mine good?
I need more.
I think you need a bit more water.
Look, mine's gone hard, miss.
Is this good? What's the secret to this recipe, Miss?
Wow. Orange.
It looks like jelly.